In hydrology, an oceanic basin may be anywhere on Earth that is covered by seawater, but geologically ocean basins are large geologic basins that are below sea level. Geologically, there are other undersea geomorphological features such as the continental shelves, the deep ocean trench, and the undersea mountain ranges which are not considered to be part of the ocean basins, while hydrologically, oceanic basins include the flanking continental shelves and shallow epeiric seas. History. Older references consider the oceanic basins to be the complement of the continents, with erosion dominating the latter, and the sediments are derived ending up in the ocean basins. More modern sources regard the ocean basins more as basaltic plains than as sedimentary depositories, since most sedimentation occurs on the continental shelves and not in the geologically defined ocean basins. Hydrologically, some geologic basins are both above and below sea level, such as the Maracaibo Basin in Venezuela, although geologically it is not considered an oceanic basin because it is on the continental shelf and underlain by continental crust. Earth is the only known planet in the solar system where topography is characterized by different kinds of crust: oceanic crust and continental crust. Oceans cover 70% of the Earth's surface. Because oceans lie lower than continents, the former serve as sedimentary basins that collect sediment eroded from the continents, known as clastic sediments, as well as precipitation sediments. Ocean basins also serve as repositories for the skeletons of carbonate and silica-secreting organisms such as coral reefs, diatoms, radiolarians, and foraminifera. Geologically, an oceanic basin may be actively changing size or may be relatively tectonically inactive, depending on whether there is a moving plate tectonic boundary associated with it. The elements of an active and growing oceanic basin include an elevated mid-ocean ridge, flanking abyssal hills leading down to abyssal plains. The elements of an active oceanic basin often include the oceanic trench associated with a subduction zone. The Atlantic Ocean and the Arctic Ocean are good examples of active, growing oceanic basins, whereas the Mediterranean Sea is shrinking. The Pacific Ocean is also an active, shrinking oceanic basin, even though it has both spreading ridge and oceanic trenches. Perhaps the best example of an inactive oceanic basin is the Gulf of Mexico, which formed in Jurassic times and has been doing nothing but collecting sediment since then. The Aleutian Basin is another example of a relatively inactive oceanic basin. The Japan Basin in the Sea of Japan, which formed in the Miocene, is still tectonically active, although recent changes have been relatively mild.